So let's start for my presentation. I'm Luis and I'm from Portugal. I studied Master Electronics Engineering and Computer, and I have 8 years of international experience in software testing and development. I am TQB certified with Management 3.0, and currently I'm department lead, tech lead, interviewer, and trainer. That are the roles that I'm doing now in my current job. And I work in some industries like automotive, energy, health, and kitchen. So, after presenting myself, I would like to say to all of you, welcome to this meetup, and let's start to present the topic for today. I would like to start to present our agenda. So, for today, we have some kind of topics. At first, I will give you one introduction, present to you some agile methodologies, and share a clarification about this topic. After that, we'll have a look on traditional and agile more deeply in terms of what kind of methodologies you know from each side. Then go one by TDD, BDD, FDD, and DDD. So for software development methodologies that are used in industry, then we will go a bit deeply in each one of them. Each one of them follows the same structure, and in the end, we will talk about the conclusions from our presentation with some kind of summary where we represent the differences and the parameters that can be used to differentiate each methodology that I present to you. Then open space for questions and answers, and you can also leave your questions on the chat and I will answer in the end. So let's start for our introduction. Basically, the purpose of this presentation is introduce software development methodologies. As I referred, 4 of them: test-driven development, domain-driven design, behavior-driven development, feature-driven development. So they have some kind of benefits that are common to all of them. Basically, they improve of the code quality, reduce of errors and rework, and alignment between teams and business goals. So that are high-level positive points about them. But in our presentation, we will have a look in one by one what exactly are the objectives, the definitions, and what is defined in each one of them. We will follow this structure. I will present to you the key concepts about that, then some practical examples, and in the end, one comparative analysis with this. So let's start for traditional methodologies. So as we know, there are some kind of methodologies that were used for a long time in the industry. For example, the waterfall model, as we can see here, V model, spiral, incremental model, iterative. So all of them are considered traditional methodologies that were used, and some of us probably already worked with some of them in some different projects, applying different methodologies or combination of that. Then, a bit later, let's say, appears the agile methodologies. So these methodologies are more recently used, and we have here some of them. For example, Scrum, Kanban, extreme programming, Lean. So all of them are considered agile, and a big part of the projects are currently using Scrum. So I'm giving this introduction just to locate where will be our software development methodologies. Are they traditional? Are they agile? No, they are not traditional. They are not agile. And based on this comment, I would like to do this clarification that DDD, BDD, FDD are not agile methodologies on their own. So they are not agile, they are not traditional, but rather than practices and techniques that can be used within several agile methodologies and improving software development. So basically, these methodologies can be used together with agile methodologies, but they are not by themselves by agile methodologies. So it's important to clarify, because in some projects or in some people, I found that it's the concept that it's not 100% clear, and I would like to share this clarification with you. So it can be used together with Agile, but they are not considered Agile methodologies, let's say, officially in theory. So let's start for the first one, behavior-driven development. And here is the first methodology that we will have a look. And this is a methodology that it's focused to ensuring that software meets business requirements by addressing how the system should behave. So it's based on the behavior, as I referred. We can see in this picture, BDD is here in the middle. If we divide it in two parts, business and technically, we have BDD here on the middle. So not extremely business, not extremely technical. Here, some kind of mix between them. It's based on test-driven development, test first. So it's used to say that this methodology implements first the behavior definition and then the implementation. In TDD, first the tests and then the implementation. So it's because of that they are quite similar. And here we can add that more collaborative and business-focused approach. Here we can see the main objectives of this methodology, basically improve the communication between all project stakeholders, align the team around clear requirements, and ensure that the developed features meet customer expectations. This methodology requests us that the communication should be really close, and the people from business representation and developers and testers should be really connected to define the behavior of the system. And they need to communicate in a common language to allow, understand, and clear know what really the behavior of the system should be followed. Here we have the key concepts of this methodology. So basically, as I said, the specification is done in natural language that make it more easy to understand and more clear for all team members, not only from the product, but also from testing and development. Encourage the use of concrete examples to define how the feature should behave in specific scenario. And here we have a particularity of this methodology. The scenarios are written in Gherkin, structured language, easy to understand. Basically, we have some kind of keywords where we have given, describes the initial context or precondition, when specifies the action or event taken, and then outlines the expected outcome or result. So we will see a practical example about that, but this is one of the main points regarding this methodology, the description on this mode, given, when, and then. And basically, here we can create scenarios of behavior of our system, that it's based on that. So some advantages and disadvantages about this specific methodology. It's really good in terms of improve the communication because developers, testers, and product people need to communicate constantly and share scenarios, share questions, share additional information to allow create this common understanding. Clarify of requirements. The requirements are clear because we have this structured, let's say, given, when, and then that allow us to understand exactly the specific requirement. And it's focused on behavior than purely technically. As we saw in the previous diagram like this, it's not pure technique, but also includes some business area on this methodology. So the disadvantages are learning curve. Yeah, for teams that are not familiar with this methodology, with Gherkin language, it can be a bit tricky at the beginning, be familiar and follow the rules of that. And in the end, the complexity, because the time and effort to design scenarios can be considerable, because in the market, we are talking about complex scenarios and to derive complex requirements, and to derive scenarios for that, it can take some time and effort to put them not only defined, but also defined in a clear, common understanding and good language. So when should we use this methodology? When we really need clear alignment with the requirements. So when this information, these requirements must really need to be clear, need a close communication between stakeholders, and work with complex requirements who need concrete scenarios. Because with this, we have, let's say, a complex requirement that we will create small scenarios to cover this requirement with easy way to understand and covering the different parts of this requirement. And here we have a practical example how to apply that. For example, imagine this requirement. This feature allows users to log in to the system. A user with valid credentials should be able to access to the home page after logging. Of course, I choose a simple example to bring for us today and to be more easy to understand. And basically, we can rewrite this requirement with something like this, like a feature of the requirement where we say, as a registered user, I want to log in the system so that I can access my account information. And based on this feature, we can derive two scenarios. For example, successful login to the system and unsuccessful login with invalid credentials. And here we have the keywords of this methodology. Given the user on login page, when they enter valid credentials and click login, then they are redirected to the home page. So it explains clearly the behavior of the application in this example. Login page, valid credential, click login, then go to home page. The behavior is absolutely clear and understandable for everyone. Here exactly the same, but for other scenario. The user is not on login page. They enter valid. This is on login page. They enter invalid credentials. Click on login and enter message. Invalid data is displayed. So two different examples. Of course, here you are looking to a really simple scenario, simple case. But of course, in big projects with more complexity and more complex requirements, it can be a bit more, let's say, hard or complex to implement. But this is the main point to have from this methodology. So behavior-driven development. So then we will have a look for domain-driven design. So here we have the diagram again to situate us where we are. Now we are here on the left side. It's more focused on business than BDD. And that techniques can work together. So let's say practically them can be applied together in the same project. Nothing says that if I use one, I cannot use another one. It's possible to use some of them together. And basically this one is focused on the core domain to create shared understanding for developers and business stakeholders. So it's quite similar to BDD, but BDD is focused on the behavior of the system. How should the system behave? Here, it's focused more on the business domain. It's quite different, but with some similar points. Emphasize close collaboration to ensure that the software accurately reflects business process and logic. So it's important keywords: business, process, and logic, more than behavior of the system. Then we have here the main objectives. So align the design of software systems with business domain. Software is well structured, maintainable, and scalable while also delivering value to the business. So here again, focus on business value. Development of the software focus on the value that it brings to our business, and create modular systems with clear boundaries. What it means? This methodology requires to identify different contexts that should be clear and divide in different parts. We will see better in the practical example about that, but this is one of the key points of this. In terms of roles, developers and business stakeholders are mainly involved on this field. We have here some kind of key concepts where we have use of the shared language that both developers and domain experts can use. Of course, here is not the language that we used it in the previous one, in BDD. We can use, but it's BDD and DDD. Here, the language is not completely done in this way, given when and then. It's one difference between them. Divided into bounded contexts, ensure that each part of the system is focused on specific areas of business. As I said, divide the system in different parts, well-defined, well-bounded, where we can apply different contexts to separate the different parts of our system. To help, they define some kind of roles like entities, value objects, and aggregates. Entities are objects that have a distinct entity and life cycle, for example, customer and order. Value objects are objects do not have a distinct identity and are defined by their attributes. They represent concepts like address or money. And in the end, we have the aggregates, a group of related entities and value objects that are treated as a single unit. So we use these concepts. We will see in the practical example how it's done in the practical way, but generically and theoretically, we use that entities and other parts. And domain service, so operations that are not naturally part of the entity or value object, but are important for the domain. So important concept to have here. They have these entities, value objects, aggregates, and also this limitation of context. Different context, well organized, well defined. Advantages of these methodologies to improve alignment with business, complexity manager, so breaking down the domain into smaller, more manageable parts, so bounded context, as I explained. We have a complex system, and it will be derived in bounded context. Scalability and maintainability, because the system is done modularity, because of the bounded context that we have, different contexts, different models, and shared understanding. Of course, as I said, not the same language as we have in BDD with given, then, and when, but with some common understanding with the previous key concepts that I present in the previous slide. In terms of disadvantages, we have here the same as we have in the previous one, learning curve, so team familiar with the method and the language. So this business approach can take some time in terms of developers more technical, more familiar with technical stuff, can take some time to acquire this mindset. For small projects, it might introduce unnecessary complexity because the project will be small and we are applying these context-bounded language understanding and things like this, and we are adding complexity, but for really small projects, no, there is not a lot of sense to apply this extra complexity for something really small. Maybe with other methodologies will be better to develop in this case. And time intensive, because the process of modeling and collaborating with domain experts can take time. Yeah, in this case, because the business should be absolutely aligned with the code, with the project, let's say. And modeling these contexts bounded can take some time because it's important to define the architecture, define the organization, how it needs to be divided, and this kind of things can take some time. So when should we use BDD? The system being developed is complex. So for complex system, because we derive that on different contexts clearly, needed a close communication between developers and domain experts, and work with deep domain knowledge and flexibility in the system design. So it's quite similar to BDD. Here we have one example for this case. Imagine that we have the domain bookstore and we have a scenario called customer orders a book. So here are some entities and aggregates. For example, the customer is an entity with a unique ID and personal details. And here we already are modeling. We already are saying, okay, we will have customers that have one unique ID and personal details. We have another thing, order, an aggregate that includes order ID, customer details, and list of purchased books. And book, an entity that could be part of the inventory content. So here we can see different entities, different aggregates that can be defined in this context of customer order a book. Here is an example of different bounded contexts, because to order a book, we can have here, for example, two contexts. Order management, it will be a context well-defined and bounded, and of the creation and processing of orders. And we can have another different context, inventory management, tracks stock levels and ensures that ordered items are available. So we cannot say that they are absolutely different and independent contexts. No, they are dependent and they interact one to each other. But in terms of definition, in terms of analysis, they can be seen as two contexts bounded that interact one to each other to complement that. And here we have a practical example about that different approach from DDD. So now go to the third one, FDD, feature-driven development. This one is not present here in our diagram because it's hard to quantify this or locate this approach in terms of business and tech, because it may be somewhere on the middle or can be applied in all of the diagram, because it's focused on delivering working software in a predictable and efficient manner to a focus on features. Basically, the product or the system, it's divided in features, small features that are implemented feature by feature in the time limit definition. It provides clear milestones and ensures that the team remains focused on delivery specific client value feature. So, based on my experience, this is really used in a lot of projects, and it's matched a lot with Scrum, where we have the prioritization of the features that will be implemented. We will implement it feature by feature. We will prioritize the client value features. So this methodology is really, really close to that. And the principle is this. Here we have the main objectives. So we provide structured approach to software development that ensures the timeline delivery of software features. So it's structured, and we have defined timeline and milestones. Okay, we should deliver these features until this date, that feature until that date, and things like this. Of course, this is the planning, but in any case, it's part and a characteristic of this methodology. Organize the development process around small and well-defined features. So the development process is focused only on features. And features are selected and developed iteratively. So iterations, like sprints, for example. And we have here feature owner, architect, developers, can also include testers here, but basically is this the workflow. We have the key concepts, basically the features. I guess it's a common understanding for everyone, that are small client valued functions or behaviors of the system. Features list, collection of all features to be implemented in the system. We have the feature list, and then we can prioritize them and implement in some time definition frame. We have here 5 basic processes. Basically, create the initial high-level domain model of the system, where we have my system as one. Then I will break it in system small parts in client valued feature. For example, login, recover password, and other ways. Organize features and plan their development in short time-boxed iterations. So define the time iterations and what features should be implemented in each one. Design by feature. So the design for each feature is done involving modeling and design before implementation. So the model and design are done before implemented. And develop the features and integrate them into the system incrementally. So I have my system, I add some features, then more features, and later more features. So advantages here. Predictability, because we have a planning about the features that we want to implement in a specific time frame. Focus on quality and client value. Scalability and visibility. Visibility, because we can follow the progress on the product, how much features are already implemented, how much features are missing. Scalability, it's related with the modularity of our system, where we have different models that are part of our system, and it's more easy to do the scalability of that. Disadvantages, it's a bit rigid in terms of features definitions, because after define that, it's a bit strict to update some things. Overhead for small projects, and heavy initial investment. So this work to analyze the system, define the features, and this stuff can take some initial investment on that. About when should we use this methodology? The project that involves when the project involves a large, complex systems with many stakeholders, clear and structured management of features is needed, and the system is expected to evolve over time with frequent new features being added. So, as I explained, divided in time, added features, and turn the complex system in small and different features to be more easy to implement and track the progress of the product. Here we have the same example of the previous one. Here I choose mixed them, BDD and FDD, using the language here. And basically we have here customer orders a book. So then we have the feature lists, for example, allow customer to view available books, allow customer to add a book to the cart, to the chart, allow customer to place an order and receive a confirmation. And then, based on one feature, we can create a feature design using the BDD, for example, or not, is our option. Given the customer has added book to the chart, when the customer places an order, then the order is confirmed and the stock is updated. This is one practical example how to apply this technique, and I can, as I shown in this example, it can be applied together with other ones, for example, as BDD here. So now I will present to you the last one, test-driven development. So based on my experience, this is one of the most used in terms of some projects. And let's have a look for that. Here we can locate that it's located in the tech part. So it's more focused on technical stuff than in business, as we saw in DDD and BDD. We can see that it's focused on delivering software in predictable and efficient manner, time focused on features. And we have this time defined also, and this tech predicts implement the tests before the implementation. Here we can see the main objectives. So ensure that the code is fully tested before implemented. So first step, implement the tests. Second step, implement the code. And other objective is create clean, modular, and maintainable code. We also have feature owner, because it's based normally on features, where we derive our test cases, applying test techniques, and the testers and developers have a close communication, and the code is being refactoring in cycle, as we will see in the next slides. A key concept here is the red-green refactory cycling. Write small incremental pieces of the code, and often uses mocks, objects, and stubs to simulate the behavior of external dependencies. So it's very used in unit tests, and we have our model or component under test, and we mock the interfaces outside to isolate that. It can be also applied using this refactor, as I said, and basically we write the tests, the developer implements the code, the tests are failing, the developer rework the code until the tests are passing. Here it's more clear how it works. So basically the design of the test case is created here based on the requirements. Then the developer will implement the code. The developer after that will run the tests. And if the tests failed, okay, the developer rework the code, implement the code, and run the tests again. And it will be in this cycle until have all the tests passed, and we can consider the feature or the unit is already implemented and done. Here we are working a bit more close to the code, and this cycle is repeated for time by time, and of course includes and requests the good communication between developers and testers. So big advantages here: high quality code, improved maintainability, confidence in changes, because they are really close. We have one change and immediately we run the tests. We know immediately if our update changes or not the test cases. Disadvantages: the initial learning curve, overhead for simple features, and requires discipline. Yeah, because this process can be a bit hard to start implementing some team that it's not familiar with that. And for some simple features, maybe it could be implemented directly instead of have the tests and then the implementation. But of course, all these methodologies have advantages and disadvantages. So when should we use this? When the project requires high quality, when the software is complex. Yeah, because on this way we will be really close to the software and it will allow us to fix and operate together with developers for that. So now I have a demonstration, a quick demonstration for to share with you. Let me just switch my screen. It's basically a simple way to do this stuff about TDD. So I created here these test cases. So basically that are the way to implement a specific test environment for a unit. So this unit is quite simple. I implemented a unit that calculates the square of a number between less than and 10. This is my unit, something that will calculate the square of a number between less than and 10. So the tests are already done by testing team in this file, okay? And then the developer will start implementing that. So as you can see, this is Google tests and C++, and I will do the role of developer. For example, here I will implement my square function that receives a number. So I save my code, run the tests, and yeah, it's not running well. And because the square is not doing the expected stuff, I will add as developer here the rest of the code. And then when the developer have the code done, can run the tests. And everything is fine. 3 tests, 1 test suite run, and all of the tests done. Imagine that the developer did some mistake and run it, for example, like this. You can see here test cases are failed. Yeah, because the function I defined, let's say that the error out of boundaries should be 999. Imagine that me as developer write this wrongly, and okay, I will switch it and put it like that. Run the tests, they fail. Okay, I will refactor my code and will paste here the correct error. I will run my code across my tests. And then all are passed. And this is the cycle that we repeat. Tests first, then the developer implement the code until have all tests passing. So let's come back to our presentation. And then let's have a look on conclusions. So here I put this table that compares the different methodologies and talk a bit about each one of them. It's useful to allow us understand the difference between them and the focus. But summarizing, FDD, the feature prioritization variable, delivery variable, and derives the system on features, and they are implemented incrementally and in specific frames of time. TDD, test first, refactoring the code, and developer refactoring until all tests are passing. BDD, based on the behavior, based on give, when, and then scenarios, and DDD, based on business and domain models for our business product. So here to finish our diagram, as I explained before, TDD is absolutely more technically. We have BDD with given, when, and then keywords that it's in the middle of business and technically, and DDD that it's deeply focused on business side. Then FDD can be applied in all of the range. So that's all that I had to share with you today about methodologies. I would like to say thank you for all, and I would like to open the space for questions while I have here the feedback QR code to fill. So I guess now we can open the space for questions. Okay, let me check the chat if you have any question. Which methodology is the best if the project has LLM or any data science? So it's more related about the complexity of the project than has or not some specific technology. I would say that on this case, it's better to combine different possibilities of that things. Maybe I would say that would be a good approach. Use BDD and DDD to derive different the system in different small parts, focus on the business, but at the same time deep technically to allow track and do the stuff correctly. Another question: are QA testers mostly involved in TDD? Yeah, this is right. So the testers are more involved in TDD than in the other methodologies. Yeah. Let me check if we have more questions. Okay. So as we don't have more questions, I would like to say thank you for all. Thank you for your interest. Thank you for your participation. Please scan the QR code. Leave your feedback. It's important for us, and we can close our session today. Thank you, and have a nice day.